we have to compare the two options and bring them to parity, i.e. make them the same, make them equal, such that the investor, in this case, would be indifferent between the two interest rates, between the two deposits. So the first option is to invest, let's say, we'll do both. Let's say we invest in dollars. So if we invest in dollars, $1 will get us how many dollars after a period?
1.
Yeah, so let's do them actually in with symbols. It gets us 1 plus the interest rate. Okay, and here I can do them with numbers. So $1 invested at the interest rate for dollars will get us 1 times 1 plus the interest rate. What is the interest rate for dollars?
7.
Yeah, 7. Now, later on in the question, actually at the beginning, he said that the forward rate is 180 days. So that implies that our deposit, the term of our deposit is 180 days. And the exchange rate, the interest rate is an annual rate. So, yeah, 3.5%. So the 7% per annum is a 3.5 for half a year. Okay, and so that is one option, and this gives us at the end an amount in dollars. Now there is another option to convert our dollars, our $1 into the other currency, which is Swiss francs. So how many Swiss francs? Does $1 get us?
1.407.
Yeah, it is essentially S, this number, whatever number is here. Symbolically, it is S, right? So it will be just S here. If the exchange rate is written like that, with Swiss franc on top. Okay, and in our case, $1 will get us how many Swiss francs? 1.4706, yeah. So 1.4706 Swiss francs. So this is $1 converted to Swiss francs. And this is invested at the Swiss franc interest rate, which is the unknown. This is the X in the question. Okay, so this is invested at 1 plus the Swiss franc interest rate. So at the end of the period, you get S times 1 plus the interest rate. Now this is an amount in, so this is an amount in what currency?
Swiss.
Yes. And this is an amount in?
Dollars.
Yes. So they're not really comparable. So we need to bring them to dollars to be able to compare them. So what do? We multiply or divide by the forward rate, because this is today, and this is in 180 days, right? In terms of time period. So F in 180 days is 1.4295. Do we divide or do we multiply?
Divide.
Yeah, so now I want to bring this right back to here to compare. So I'll rewrite so that it's not so confusing. So we have the $1, and we want to equal it, right? We want to bring parity. We want the two options to be equal with the second option. So option one, investment in dollars, with option two, investment in Swiss francs. But this is an amount in Swiss francs, so we need to convert this amount in Swiss francs at the forward rate, which is, sorry, 1.4295. Do we divide or do we multiply? This is an amount in Swiss francs.
Divide so that it
Yes,
cancels
very good.
out.
So here we divide. So this is what we're doing. So this is the equation. Or we can generalize in symbol terms this equation here. So we have 1 plus r dollars should be equal. So this should be equal to this amount converted. So I'm just copying this. So in this way we have derived the interest rate parity condition. Yes? And we can do it the other way around with 1 Swiss franc. If we had 1 Swiss franc, we invested at the Swiss franc interest rate, or we convert the Swiss franc to dollars. 1 Swiss franc is how many dollars? 1 over. Yeah, so it's 1 over S. Then we invest that, so 1 over S Swiss franc dollar. We invest that at the which interest rate? The dollar interest rate. And then we convert back to Swiss francs. So this is a dollar amount. So we multiply this time by F. Right? So we can have this condition either like that or like this. So this would imply I'm just copying things from this. This is the exact formula because this is the actual derivation of IRP. Or you can also, if you do memorize it, if you rearrange this, you can rearrange them such that they're a bit easier to remember. For example, you could remember it like that. Plus R dollar. So this is CHF over dollar. And this is CHF. Right? So we bring this here, and then we bring this on the other side. So we have the ratios of the forward and the spot rate, and the ratio of the two interest rates. If you want to, or you can just derive it and work based on that.
I, is it I over here?
Is one, sorry.
Okay.
My one is like that.
Oh, that's fine.
So this is 1 over S. Because now we have 1 CHF. How many dollars does it get us? Right, because $1 gives us S CHF. Now we want 1 CHF. How many dollars? X. X is 1 times 1 divided by X.
For the midterm, I think you said it's like 4 marks per question, right? So you're wanting working out for each answer that we give?
No, so it's multiple choice.
I know, but so there's 4 marks per question though, right?
Yeah.
So it's just 4 marks for giving the right letter. Like we don't need to do all of this working
Yeah,
out.
exactly. Yeah,
So
but
if we
giving the
get
right
it,
letter implies knowing. Yeah.
so if we get it wrong, then we get 0 out of 4.
Exactly. So it can be quite taxing.
Right. Okay. So either 4 out of 4
but
or
don't
0
worry,
out of 4.
students in many, I've taught this for 3 years now, or 4, I can't remember. They do very well in the midterm. Yes, but in the midterm, you use this formula. So this.
Right.
Yeah. So as long as you use this and put this in correctly, you should be able to get the rest is just arithmetic.
We don't have a formula sheet or anything, right?
No. So that's why I emphasize and say that this is important. Now, do you understand it? Shall I repeat a part of it? Any part of it? Yeah?
Can you just repeat the second half, like 1 CHF after that? This part, not that.
This one.
Yeah.
Yeah, so what I was saying here, that you can do it either this way or that way. Basically means or involves writing that formula differently. So in whatever way you write, it doesn't matter.
What is
So-
this way? Like
Yeah.
what?
So you invest in one. So let's say you start with $1, and there you start with 1 CHF.
Oh, okay.
That's
Just
all.
reversed.
Yeah,
The
exactly.
reverse. Can you please sum it up, like the whole thing?
Yeah. So I would start with $1 because the way the exchange rate is quoted. So whenever you have a question, you look how the exchange rate is quoted. That will tell you everything. It will set your thinking in terms of the dollar, because the dollar is the denominator. So then you quickly derive this. Shall I go through that? How we derive it? Okay, once we know this, either in symbol format or with numbers, so just replacing that with numbers, all we have to find out now is this. This is our unknown, RCHF. And whenever it comes to interest parity, what you need to remember is that transformation for the rates. Interest rates are always quoted per annum, but forward rates can be of a different time period. So we want to be consistent in this equation. We don't want to have different time periods, because the deposit is for 180 days, the forward rate is for 180 days. So that's why here we transformed the R dollar from 7% to 3.5. Right, and this is a half a year forward rate, which we are given. So all we have to do now is find R, and this is simple arithmetic. Have you got an answer for R from this equation? Now, I hope you wouldn't find this difficult, this type of arithmetics, right? Hopefully. Oh my god. So let's do it to be sure. Now this is 1, right? 1 plus this, what is this? 1.03. Do you agree?
Yeah.
Equals 1.4706 times 1 plus our unknown. Divided, but I'll write it here, divided by 1.4295, right? Okay, so now depends how you want to do it. You could do this and this, or some students did this times this divided by that.
Yeah.
So 1.035 equals, if you do this, how much do we get? This is the ratio here. This sum
1.028.
Okay, very good. 1 plus r. So then we find 1 plus r. Right? 1 plus r. This is 1.
0.8.
Is this divided by that? Yeah, that's
0.8500. 1 minute.
wait, so I think so first it has to be bigger than 1. Right? And now what is
one
r? Is that amount minus 1. So
6.8% is come. It's coming. 0.6.
So 1 plus r is 1.0. R is 0.6%. What else do we need to do? Yeah, you see? Yeah. So times 2 will give us 1.2 approximately. So this is a per annum rate. Because this rate was only for 180 days, which was consistent with our F. The F was for 180 days. And that's why we transformed this from a per annum to a 180 day. Yes? Okay. Then the next one. Can I erase? Now the next question will be similar, but we won't have equality. We will have one side bigger than the other. When we have equality, means there is no profit, right? The two are the same, so an investor will be indifferent, right? When there is inequality, the one bigger and one smaller, then it means that there is a profit. So no longer the investor would be indifferent because one side is different. So whenever there are differences, there would be a different pressure. So the question tells you you borrow in one currency and invest in the other, and it doesn't tell you which. So in this question, which is a bit longer, you have to try both. So first we will do borrow in whatever, so let's say euros, and then we do the other one. So the first one, so we borrow euros and invest in Malaysian ringgit, and the next part we do the reverse. We borrow because we want to check both options and invest in euros. Yeah? So, and then we need to compare these two options. This is a carry trade because you borrow in one currency and you invest in the other. It's the same thing as investing, just what we had before, investing in euro compared to investing in Malaysian ringgit. So the logic is the same. Whenever you borrow, you owe that amount, right? Because it's a loan. Whenever you invest, that is an amount you gain. It's an inflow, right? Okay, so when we borrow in euro, so let's say we have 1 euro. If we borrow it from the bank, after one period, what do we owe? Well, we owe 1 euro times the interest rate. Which interest rate? Now we have, in this example, we have bid and ask rates for the exchange rates, and we have deposit and lending rates for the interest rates, right? So the bank will always deposit our money at the lower rate and lend us at the higher rate, and they make money from the difference. So we said we are borrowing euros, so which, the deposit or the lending rate for euros should we use? Yes. So what is that? Euros. So 6 point. Yes, 6.125. Sorry, it's 1 plus, so I can write it in longer. 6.125%. Versus investing in Malaysian ringgit. So now we borrowed 1 euro, we have it. This is the euro. We're going to invest it in Malaysian ringgit. What do we need to do first? Exchange, yes. Some of you said exchange, right? So exchange 1 euro into Malaysian ringgit and then we invest it. So this is a euro amount, so this is a euro amount. So we have 1 euro. Which rate should we use, the bid or the ask? The exchange rate is quoted as Malaysian ringgit over euro. And we have 1 euro, we sell it to buy Malaysian ringgit. So, so we sell euro. The bid, yeah. The bank buys. Clear? So we use the bid rate, which is 4.6602. So 1 euro gives you 4.66. I can delete this now. 22. This will be an amount in Malaysian ringgit. So now we have, with 1 euro, we transformed it and we got 4.6 Malaysian ringgit. This invested at the Malaysian interest rate will give us something in Malaysian ringgit, right? What is the interest rate that we should use? So we are depositing
Euro.
10 point? Yes, 10.5. And this is an amount in Malaysian ringgit. It's not really correct to compare it to the euro amount. One is in apples, one is in pears. We need to transform this into euros to be able to compare, right? So we need to convert this Malaysian ringgit amount at the forward rate in the future, at the end of that period, to compare to euros. So which rate do we use? The bid or the ask for the, this is the exchange rate. Yes. And do we multiply or do we divide? Yes, divide. Is everyone clear? And the rate is? Which is the rate? Wait, can anyone spot a mistake?
The ratio, the
So here we have €1 and we have euro and we sell euro. The bank buys, yeah. So we should have used the bid,
that's what
right? So we should have used the bid rate. And here we have Malaysian ringgit, we sell Malaysian ringgit, and we buy euros. So therefore the bank sells euros. So then here it is the ask. So here is the ask and here it is the bid. So the ask is 4.965. Yes? And the rest of it is arithmetics. So we just have to calculate what number we get on the left hand side, right? 1.06, 125, versus what we get on the right hand side. So on the right hand side, has anyone got the number? It should be 1.03 something. So obviously this left hand side is bigger. So what does that mean? Do we make a profit or not? No, yes. So we don't make a profit because what we owe is bigger than what we gain. So we will try the second one. Borrow Malaysian ringgit. So 1 Malaysian ringgit borrowed will mean that we owe, at the end of the period, 1 Malaysian ringgit times 1 plus the interest rate. We borrow, so which interest rate should we use? 10 point, yes, 625, the higher one. This versus, now 1 Malaysian ringgit, we borrowed it, we have it, we convert it to euros. So we sell Malaysian ringgit to buy euros. So now we buy euros. So,
ask.
yes, ask rate. So the bank sells. So we use the ask rate. So the ask rate is, where is the ask rate? 46622. Okay, and we invest for 1 year. So in this example, we don't have any transformation to the interest rate. So what is the interest rate I should use? So we're investing in euros. We invest so the bank will quote us 6 point. We invest in euros 6 point. Uh, 6.06, yeah. So the lower rate. When we invest, the bank will quote us the lower rate, because that's the rate they give us for deposits or investments. Okay, so what is this amount? What currency? Yes, euro. So now we transform the euros. So we sell the euros. So therefore the bank buys. So we will use the bid rate. Yes? So we use the bid rate, which is in 1 year's time 4.95. Do I multiply or do I divide? So we have an amount in euro. Yes. So then again, now it is arithmetic, so we should have a value on the left hand side and compare it with the right hand side. So on the right hand side we should have 1.10625, and on the right hand side we should have 1.125. So this is bigger. So this is what we owed from borrowing. This is what we gained from investing.
Profit.
So is this good or bad?
Profit.
Yes, so this is profitable. Now in the next part we need to find F. Any questions? We need to find F here. F, this was F, remember? So we're going to replace this number with F an unknown, and we will solve for it, such that these inequalities don't stay the same necessarily. So such that the inequalities imply no profit. So in the first one, do we change the inequality? For no profit condition. Do we change it? No, because already this inequality, this way, leads to no profit. Right? It already leads to no profit, and we want to set the inequality such that there is no profit, which in fact it is here. In the second one, we want to set the inequality such that there is no profit. We don't want to have the face. We don't want profit. So the inequality will be the opposite. So here we change it. So we set the inequality such that there is no profit, because that's what the question asks. Find F such that there is no arbitrage opportunity, which means there is no profit opportunity. Does it make sense? Right? So we change the inequalities and then we solve for F. So we have one unknown from two inequalities. So right now I'm copying one again, which is the left hand side is 106125 and the right hand side is times 1.10, so 10 okay, divided by f. Now I'm replacing this with an unknown because we want to solve for f so that the inequality is in this way. And from the second one, I'm copying it again with the direction of the inequality the right way. Times f. And now we have a system of two inequalities and one unknown, f. Yes? Shall I repeat any part? Are you wondering why the inequalities have changed? Stays the same. Yes, the first situation stays the same because the first situation already we were unhappy, i.e. no profit. Because what we owed, so this amount was bigger than this. So what we owed was bigger than what we gained. So if you have to pay more than what we gain, than what you gain, then there is no profit. There is a loss. So it means that the way this inequality is correct. So we keep it the same. Now in the second one, we want to re-evaluate this such that what we owe, the left-hand side is always what we owe because we borrow. When we borrow, we owe something. The second part is when we invest, we gain something, right? So now what we owe from borrowing is less than what we gain. So that's good because it created a profit. Now, in light of question B, we want to eliminate this profit. So we want no profit. So if we set this inequality such that what we owe is greater than what we gain, that means we pay out more than what we get or gain. So that's why we corrected this. Just because we want to set it such that we eliminate profit. Because we want to find the no arbitrage range. So then we rewrite these two inequalities with the right way of the sign, and with f as our unknown, and we solve for f. So from the first one, we should get f bigger than something, and from the second one, f smaller than something. And this is again just arithmetic. We have to do the calculation. Did anyone do it? Yeah, what is the
No,
first
I
one?
didn't do it.
So the first one is f bigger than 8. 4.8523. And the second one is 8656. So f has to be between this range. That's what we wanted. As long as f is between these two values, there will always be no profit. If f is not outside of that range, there will be profit. So that's all that the question asks us. Any questions? Any part that is unclear? No. Good?
No, it's
Okay. Does it seem complicated? Okay. Well, I hope that once you revise again the answers, you can redo them if you want, but without looking at them as a test, then that should help. If you have questions on this topic, let me know, either at the end or sometimes process next time. So now the last one we can do. The answers are there anyway, but I will try to do most of it. It is the money market hedge, and in this example, this is a good example to start with. Now there are 4 examples in the lecture, towards the end of the lecture, 3. So you can do those as practice. Again, even without looking at the answers. So there are 4. 2 payables, 2 receivables. But before you do this is a good one to start with. Because if you look at question 3 now, you don't have bid and ask rate, and you don't have deposit lending rate. It is much simpler. So it really, now you can understand and illustrate the money market hedge more clearly without the complication of the bid and ask rate. So that we know exactly what we're doing without worrying which way shall we choose. So we are an importer. We are Japanese and we import something from the US. We have a payable in dollars. So we have a payable in foreign currency. If the dollar goes up, what happens to our payable, which is in dollars? Goes up or down? Yes, up. It always moves 1 for 1, whatever this amount is. If this amount is a payable, that's bad for us because we have to pay more. But if this amount was a receivable, it still goes up, right? Irrespective. And that would be good. So it depends on our position, whether we have a payable or a receivable. Depends on our transaction exposure. So that is good or bad?
Bad.
Bad, because now we need to pay more. Payable increases. If the receivable was going up, that would be good, but it is a payable in this example. So we have a payable. Now this payable happens in 90 days time. And this payable is 37287. So this is a payable in 90 days time. So let's say that we have the same colors. So I have a payable in the future. So this is now. In the future I have a payable, i.e. an outgoing. So it is pointing towards you because from me it is an outgoing. If I hedge it with an incoming, so an outflow hedged with an inflow, so arrow coming to me, in the same currency of the same amount, these two would
Cancel it.
yes, so that's also called a natural hedge. They just offset each other. One is an outgoing, completely offset by an incoming. So a payable in foreign currency, we can offset it by a receivable in foreign currency. Yes? Payable offset by a receivable. Receivable in foreign currency means a deposit. So this hedge requires us to deposit in a foreign currency account. But first I need some money to deposit in a foreign currency account. So I will have to borrow. Maybe I don't have it. I will borrow my currency. It's red, so it's a different currency. I will borrow it, convert it into the foreign currency, and then invest it. and then invest it, yes? Such that when that investment matures, it completely offsets this. And what I'm left with is just this borrowing, because I still borrowed, this doesn't disappear. And this is time t. Yes? So that is the idea. To solve it, we move back, because what we have is this value. So we need to move backwards. It's a backward induction type. So we need to go from a future value to a present value in foreign currency, and then see how much that is in our currency, so that we know how much do we go and ask. Because I need a red pen. How much is this? I need to ask the bank. So that's what we're doing. So we have, so this is a future value, right? So we need to bring it back to present. So what do we do to convert the future value to present value?
Divided by this.
Yeah, exactly. We divide it, or we multiply by the discount factor, which is 1 over the interest rate. So we divide it by 1 plus the interest rate. The interest rate for dollars. And now we don't have the complication of which one should we use. We just go to the intuition so that it flows. The interest rate for the dollar is 3.25. The only thing we have here is, yeah, this is a per annum rate, and we need a 90-day rate. So this little transformation. So what is this? Sorry? 374. 92. Thank you. So we always know that the present value should be less than the future. Yeah, because the present value grows to a bigger value in the future. Okay, so what does this mean? This is the present value of this amount in dollars, which is our payable. But it also means that it is the present value of this receivable that we want to get to implement this hedge. So we know this is the present value. So this is today's, in today's money. This is today's value. We have this, and we want to make an investment. We want to deposit this money in a foreign currency account, in the dollars, so that this money grows from 374 to 377. And when that happens, our investment matured, will pay off the 377 payable. Right? So the 377 payable will be matched by our 377 receivable. Yes? Now, this now this 377 in the future is 374 in today's terms. So now I know that I need to get some currency, some yen. Is it yen?
Yes, Japan.
Yeah. I need to get some yen and convert them such that I get this amount. Let's say I don't have these yen. I will borrow them. So I need to go to the bank and ask. So the bank, the yen bank, will tell me how much yen do you want. Well, give me a second. I need to calculate this into yen. Yes. So this is the next step. To convert this to a yen amount. So this happens. Yeah. Again, we don't have any complication with the rates. So the spot rate is 106. I just changed the example so that do you have it? class here? Okay. Okay, they have a class, so I thought that there wasn't.
Multiply, we have
Multiply, yeah? So we get the yen value. So now we know how much this yen value today we can ask the bank. We know what was the bank. And this yen value that we borrow today will also grow in the future. So after 1 year or whatever,
90 days.
90 days, we owe this plus a bit, right? That's a future value. And then, and that's it with the money market hedge. Now, this question also has a separate question to equate it with the forward hedge. But this is the money market hedge. So that the forward hedge we've done before. So the important thing is that you have now seen, it should appear here for your and then you have seen now the money market hedge.